In a previous video, I had started to point towards this formula, taking the conditional probability and multiplying both sides by P of B to make a slightly different version of the same formula, which is now written right here. All right, but what if we know that they are independent? Well, if we know they're independent, that's where this piece came from, because P of A given B is the same thing as P of A if they are independent. Right? This is called the multiplication rule, because if you know two or more events are independent of each other, then the probability of those events happening is just the product or the multiplication. Essentially, you can put each probability next to each other and just multiply them all together for those events to happen back to back to back or at the same time. All right, again, this only works if they are strictly independent. So let's look at this, or think about this. If we're flipping a coin, here we're flipping it 3 times. Each one of those is not affected by the before or the after. Just because I flip heads on the first one doesn't mean that I'm definitely going to flip heads or definitely going to flip tails on the second one. They are independent of each other. So to find the probability of flipping heads all 3 times, we would just say, well, the probability of flipping heads is 1 out of 2. That's the first flip there. All right, I just kind of show, hey, that's the first flip. All right, the second flip, since again, it was independent of the other, our second flip is still going to be 1 out of 2 or 0.25. And our third flip is still going to be 1 out of 2. We are multiplying all 3 of these together. All right, so that's 1 out of 8. Or 0.125. If you wanted, you could multiply 0.5 times 0.5 times 0.5 instead. If you want to multiply the decimal versions, that doesn't make a difference.